Hello everyone. In today's video, we will be solving a problem based on strain energy. So here strain energy is nothing but the internal energy which is stored inside the material when it is loaded. So we need to find the strain energy here. In the question it says that a steel bar of 550 into 50 mm in section and 3 meter length is subjected to an axial force of 140 kilonewton. So here calculate the strain energy stored in the bar. Also find the extension of the bar and take E is equal to 200 gigapascal. So here in the question it says that a steel bar of 50 by 50, that means the steel bar is in the form of a rectangular. So what it says that the dimension of this bar is 50 by 50 and the length of the bar is 3 meter. So here it is subjected to a axial load of 140 kilonewton. So we have to find the strain energy. That means strain energy is denoted by the term capital U is equal to stress square divided by 2E into AL. And this formula we have already discussed in our previous video. Now here in the question it says that we need to find the strain energy and we also need to find the delta L, that is nothing but the change in length. Now see here in the question it's not mentioned like whether we have to opt for the gradually applied load or it's not mentioned. It's we have to find for the gradually applied load or for the suddenly applied load and for the impact load. So when these things are not given in the question, then we have to assume that it's a gradually applied load. So here we need to find this and this, that is strain, and the extension, that is change in the length. So here now we know first we have to find this stress value. So we know that stress is equal to P by A. P is nothing but the load which is acting in this bar, and area is nothing but this cross sectional area is equal to P by A. So P is given 140. If we convert this in kilonewton, then it will be 10 to the power 3 divided by the cross sectional area. This is the cross sectional area, that is nothing but 50 into 50 is equal to, we'll get the answer around 56 Newton per mm square. Okay, next we have a value for E. It's already given in the question, that is E is equal to 200 GPa. So if we convert this GPa to Newton per mm square, then we have to convert this with 200 into 10 to the power 3 Newton per mm square. Now we have a value for this one, area, as well as for the length. Now we can directly put the values in this formula so that we can find the value of the strain energy. That is U is equal to, strain energy is nothing but 56 square by 2 into E value is this 200 into 10 to the power 3 into what is the area, that is 50 by 50 into length is also given, that is 3 meters. So we have to convert this 3 meter into mm, then we have to multiply it by 10 to the power 3, then it will become 3000. So if we solve this, then we'll get the answer around 144 into 10 to the power 3 Newton mm. Now the second is we have to find the extension. So we have a formula for delta L. Delta L is nothing but the change in length is equal to sigma L by E. We have all the values with us, that is sigma is nothing but what was the value, that is 56 into L is 3 meter, that is 3000 into E is what? 200 into 10 to the power 3. Then we'll get the answer around 0.84 mm. So here we have calculated the strain energy, that is 144 into 10 to the power 3 Newton mm, and we have also calculated the values for the extension, that is delta L, and the answer is 0.84 mm.